Hello everyone, my name is Chandrasekhar Patil. I am from SYAML. Today we are going to solve the problem functions of square matrix. To solve this problem, first of all we write the characteristic solution. First of all, characteristic equation is A minus lambda I x is equal to 0 and general equation is lambda square minus s1 lambda plus determinant of a which is equal to 0. For this, first of all we find s1 and determinant of a. For s1, the addition of all diagonal elements. So our s1 is 3 and determinant of a, by using calculator you can find the determinant of a, and our determinant of a is 2. Now we are putting s1 and determinant of a in general equation. So we write lambda square minus 3 lambda plus 2 is equal to 0. Now solving this characteristic equation, we get the values of lambda. So we write here lambda 1 is equal to 1 and lambda 2 is equal to 2. Now these are the eigenvalues. So we write, for finding eigenvectors, we write here eigenvectors corresponding to eigen value. Eigenvectors corresponding to eigenvalue lambda 1 is equal, lambda 1 is given, lambda 1 is given by a minus lambda I into x is equal to 0. Now in this characteristic equation we put the value of lambda 1. So we write determinant. So we write here our matrix. Matrix is 3 upon 2, 1 upon 2, 1 upon 2, 3 upon 2. This is our matrix, and value of lambda is minus 1 and I is our identity matrix. So we write 1 0 0 1 and x1 x2 x3 which is equal to 0 0 0 0. Now so solving this, we get our new matrix is 1 upon 2, 1 upon 2, 1 upon 2, 1 upon 2. So we write like that x1, x2 which is equal to 0. Now we consider the one equation, they both are linearly dependent. So we consider any one. So we consider first one is 1 upon 2 x1 plus 1 upon 2 x2 is equal to 0. Now we put x2 is equal to t. So 1 upon 2 x1 plus 1 upon 2 t is equal to 0. So we write x1 plus minus of t upon 2 is equal to 0. Now we get the 1 minus t upon 2 to right side. So we write 1 upon x1 is equal to minus 1 upon 2 . Now also we shift 1 upon 2 that side. Now we shift 1 upon 2 that side. So x1 is equal to minus t upon 2 into 2 is equal to minus of t. So we write here x1 is equal to minus t, comma x2 is equal to, we get t. So we find this for x1. So we write x1 is equal to minus t. Now take t is equal to 1 and we write minus 1 is equal to x1. Now this is for lambda 1. Lambda 1 is equal to 1. Now similar for lambda 2 is equal to 2. So we directly write x2 is equal to 1 and x1 is equal to minus 1. Now we want to find modal matrix P is equal to x1 x2. So we get x1 and x2. So we write P is equal to values of x1 and x2. So our x1 is minus 1 1. So we also find the P inverse. So our P inverse is equal to, let's consider 1 upon 2 outside. So we write here minus 1. Now also we find D. So D is our diagonal matrix. So we write here the eigenvalues in diagonal form. So our eigenvalues is 1 2 0 0. Now also we find e raised to d is equal to, now we shift 1 upon 2 in form of e raised to. So e raised to 1, e raised to 2, 0 0. Now we putting all P, D and e raised to d and P inverse in e raised to a form. So we write P dot e raised to d into P inverse. So here we go. We write our P matrix minus 1 1 and e raised into e raised to d is e raised to 1 0 0, e raised to 2 and P inverse. So P inverse is 1 upon 2 minus 1. Now multiplying both of these, we get e raised to a is equal to 15 10 50. So here we will find the function of square matrix in the form of e raised to a. So thank you for listening.